Hi everyone, my name is Philip Stemberger and I'm a Principal Solution Engineer here at Snyk. In this session, we're gonna learn how to produce a custom rule for Snyk Infrastructure as code. Simply put, we're gonna learn to go from this to this. You don't really see the difference? Let me help you. To this, right there. That's what I'm talking about. But before diving into the meat of this presentation, let's take a moment to think of why we need these custom rules. Surely, if a tool is properly built, you don't need to add your own custom rules. The tool will take care of all of that. And I slightly disagree here. When I'm thinking of infrastructure as code, I'm thinking of the new responsibility of a developer. See, back in the day, a developer was mainly writing an application, maybe using some open source, but today, with the digital transformation we are seeing out there, with the adoption of cloud technology, that scope has really expanded to encompass not only writing the application, leveraging the open source that comes with it, packaging that into a nice container, but also how do I deploy these containers into my infrastructure and how does my infrastructure itself is being deployed. And that comes with some new challenges that can be very specific to your own organization, to your own needs. And that's why we've produced a tool called Snyk Infrastructure as code. Now, to go back to what I was saying, one size does not fit all. You can't just say, if you got the right set of rules, that's gonna work for me and I'm gonna be fully covered. Why? Simply because you have your own custom needs. You have different policies that apply only to your company. You've got best practices that you will want to enforce. For example, if you look at ghost resources, a ghost resources is simply a resource that is poorly tagged, therefore it is difficult to track and it's hard to monitor, which means that if such resources get compromised, it might take a lot of time for you to be able to realize that that resource has been compromised in the first place, but then to track down who is the team behind it so you can ask them to intervene or to correct the vulnerability that has just been exploited. To prevent such a scenario, you will want to introduce a rule that says every resources in the cluster needs to have an owning team. If there is no owning team, that resources is not compliant and you will want to reject it. Another example would be sensitive resources. Here I'm talking about all of the resources that are critical for your business. For example, if you have some regulations that you need to follow and you need to host your data specifically in Europe, or if you have some high availability and therefore you need to be deployed in a specific region. In such a case, when those resources have been identified, you will want to enforce that their region of deployment is a very specific one. And like we did for the ghost resources, we can now produce a custom rules that will check that if a resource is being tagged as being sensitive, or as being GDPR, or as being whatever it is it needs to be, we can make sure that the region for the availability, for the deployment, is enforced to what we want it to be. And that's for me the main use cases for those custom rules, to go and implement company policies and best practices that you want to enforce with your team that might not be related to security or are very specific to the way you operate. Now that we understand the why we need these rules, let's have a look at how we can go from a global rule set that applies to every customer to something localized that is specified for you. It starts with us at Snyk with our own research team that continuously build and test new rules to make sure that we keep expanding the rule set of the Snyk Infrastructure as code product. Now, those rules, they are being packaged into a bundle, a WebAssembly bundle that we're gonna call WASM, and that bundle is then being leveraged by the CLI. Every time you're gonna run a Snyk IaC command, you're gonna be downloading that bundle from our server and running it locally. Now, to customize those rules, that's where you intervene. We're gonna need your security team to write their own rule, then bundle them into their own WebAssembly bundle, and then distribute that to each developer to make sure that it's available locally for the CLI to leverage. We're simply going to be looking at both bundles at the same time and produce the results that we've seen at the beginning of this presentation. Now, if you're still bearing with me at this stage, you really want to know how to write those rules, and I'm with you. But before we do that, and I promise we're going to do that in a second, let's have a look at some of the prerequisites that we have. The very first one is to have the Snyk CLI. We're going to need the version 1.618. That's not really a recent one, but it's just to make sure that we all have the right baseline. So if you don't have the right one, you're going to need an upgrade. Then we're going to need the Open Policy Agent. This is what we're using behind the scene to run our own policies, to make sure that your configuration are compliant with the rule set. So we're going to need you to install the Open Policy Agent as well. That can be done easily with a brew install as I have here. I'm running everything on Mac. If you're using Windows or Unix, no worries, everything is completely compatible. But we've got the CLI, we've got the open source agent, now we need conf test. We're gonna need that simply to convert our own configuration file, for example, a Terraform file, into a JSON simply because the open policy agent only consumes JSON for the input. We're going to need to write rules in Rego, and I'm going to get back to that. But this is just to understand why do we need all of those things, and why, in a second, I'm going to start writing a Terraform file, converting it into a JSON, write a rule in Rego to apply on that JSON to validate it, and then once I've got the rule I want, convert that rule into a WebAssembly bundle to then being leveraged with the CLI. In the future, Snyk will be providing an SDK that will take care of everything for you. You will simply need to provide your Rego rule, and then Snyk will take care of everything else. Now that we got a blueprint and we know where we're going, I think it's time I finally open my terminal. Being an ex-developer myself, I have to use the test-driven development approach. So let's create a Terraform file that will contain an example of what we want to validate as well as things we want to reject, making sure that our rule will behave as we want it to. So let me go ahead and paste that. As we can see, I've got 3 resources, and before we start guessing what I'm doing here, I'm going to tell you we're looking at ghost resources. That is the custom rule we're going to build together. So what we want is making sure that we've got the right team, and as we can see here that indeed I've got all the tags. This is my compliant resource. I've called it allowed. And then we have 2 examples of denied. The first one doesn't have any tag, and the other one has tag, but just doesn't have the right one. I want to make sure that I've got the owning team one. If I don't have this one, I want to reject it. That's basically the essence of my rule. So I've got my resource, I've got my example, it's time to convert it. As we said, the open policy agent works on JSON. So let's convert this. To do that, now I can just go with conf test parse my input file, and then I've got my output. Copy paste into a new file, and now I've got my Terraform file being parsed. Now that we got a Terraform file passed into a JSON object, we can go ahead and write a Rego rule. To do so, we're going to leverage the Rego playground, freely provided by the open policy agent, so you can easily access it. All those links will be at the end, so stick around if you want to know the exact address. But let's have a look at the UI. The first thing is that input section. This is where I'm going to need to put my JSON file. That's really where I want my kind of test data to be. This is what all of the Rego rule will be leveraging to run and evaluate. Then I've got my output section. This is where I will see the result of the evaluation, quite straightforward. And then on the left-hand side, I've got really that whiteboard where I can go and write the rule, and then make sure I click on that evaluate button right here to make sure that I evaluate my rule against my input and validate that into the output. So let me go ahead and clean a bit that template. We don't need all of those comments. Let me simplify things a little bit. Before we go into the rule itself, let's just play around a little bit and get a bit more familiar with how this works. So we can see here that I've got a function called hello that simply look at what's the input, look for a message item into that input, and then check that the content is walled. If I decide to evaluate, you can see that we got hello true simply because the function has been evaluated, the condition match, therefore it returns the true. So as you can imagine, if I decide to change things around, I will get different results. So let's start playing around and change this rule a little bit. The very first change I'm going to do is rename hello into deny. I don't really want a rule that say hi. I want a rule that validate compliance. I want to deny resources. So let's change that. Let's change the package name to main just to get something a bit more standard. Let's replace the input from the JSON version of a Terraform file. Now we need to change the rule a little bit. So the first thing I need is my resources. So let's go ahead and create that variable. And then we're simply going to assign it with the value of my input, resources, and then AWS S3 bucket. We can see here that I'm adding something about the name. That's going to come handy in a second. But for now, this is what we want. We want every S3 bucket to be tagged, so we're going to capture them all. Now, what we're going to be doing is we're going to be looking for those resources that I've just defined, right? Do they have a tag? And then in that tag, do I have team? Because that's the tag I'm looking after. If I don't have that, that's when I've got a problem. So let's reverse this to be saying, if you don't have a team in your tag for the resources, we've got a problem here. Let's evaluate this to see how these behave. If I'm evaluating this, as we can see, I've got that deny true, simply because we know that some of our resources are not compliant. So we know that there is instances of this rule that are being validated. But that doesn't really help us, does it? What we want is to have a message that tells us, hey, that resources here, that one specifically is not compliant. I've got 3 of them. Knowing that one is not compliant would means that I need to start searching, and that doesn't work, right? So let's add a message. To do that, I'm going to change the definition of the function slightly. I'm going to add message between brackets, and now I can define what I want this to be. If I want it to be non-compliant and evaluate again, we can see that now we've changed that true into not compliant. It's kind of what we want, but not exactly. Let's cut to the chase and replace this by what we're expecting from a Snyk perspective for the CLI. We can see here that I've got a template with a couple of attributes, but the main one we want to be looking at will be the ID. That's simply you providing an ID. Then it's a public ID. That's the one that will be referenced by the CLI. Here, the advice we have is probably to use custom and then your internal number, so your team won't be confused between the Snyk rule and the internal rules. And then comes the title. That is simply a description of what the problem is. This is just to help your team understand why they're not compliant, what kind of things they need to change. Then the type will be custom because this is a custom rule. Then a subtype, couple of other elements like the impact, the resolution. That's the kind of things you are used to see in the UI. This will be leveraging further down the line, but let's get into the good practice of adding those today. Then for the messaging, we're simply gonna reference the resources that was failing the test, so we will be able to tell the developer exactly which resources needs to be amended. Now, if I'm running this again, we can see that I've got exactly what I was expecting. I've got 2 resources, and if I look into the message, I can see it is deny 1 and deny 2. I don't see allow because it's a compliant resources. So I don't see the resources I'm not expecting. I'm seeing the one I'm expecting. For me, this is exactly what we wanted. A rule is complete, job's done. Nearly. I mean, we got the rules. Now we need to make a bundle. So to do that, let's go back into our terminal with our rule. And now we can easily convert that rule into a WebAssembly bundle by running opa build -t wasm, the name of the function we want to convert from which package, provide a name for the output, and then what's the custom rule to use as an input. Now that I've done this, I can see that I've got that archive that contains my rule, and this is what we're gonna need to add into the CLI. So let's run maybe a Snyk IaC test without any kind of extra parameters. If I'm running it, we can see that Snyk is already finding 12 different issues into my small example, but none of my custom, as expected. If I want to get them to be implemented, I can simply rerun the same command, this time adding --rules, and then link that to that custom archive I've just created. When I'm running this, we will now see that we don't only have 12 vulnerabilities or 12 issues, we go all the way to 14. And if I scroll all the way to the top, we can see I've got those 2 custom ones we've just defined. So there we go. We finally created our first rule. Before you jump ahead or maybe go make a coffee, let's have a recap of what we've learned in this session. The first thing is we bring more flexibility by allowing you to leverage the Open Policy agent to run your own rule using Rego. Then it goes beyond simply security by allowing you to introduce your policies and your best practices into the checks you're already running with Snyk today. Then we've learned how to use them. How do we write a rule using the Rego playground to create that Rego file using our input for validation? We've learned how to package and distribute those rules by using the Open Policy agent to bundle our rule into a custom rule archive. And finally, we've learned how to write these rules. By using a TDD approach, we've learned that it's easier to maintain, it's easier to check, and therefore it's going to be better in the long run. Something I haven't mentioned, kind of a gift if you made it so far, is to keep a KISS principle approach as well. Make sure that if your rule gets too complicated, if you start writing too many conditions, that is your sign that you need to break that rule into smaller chunks. That's going to be easier for the team to digest. They won't ask themselves, wait, but which condition get applied here? It's going to be clear for them which rule applies when, and it's going to be also easier to maintain. So I can see some of you jumping behind the keyboard, thinking, how can I get to that? And you've been heard. So if you want to get started, if you want to know how you can get there, dear member of the audience using Snyk in an awesome company, I'm hearing you. Here's a couple of places where you can go to find more information. The first place to look at is really the Rego language. We're going to have to understand better how to write rules, how does it work. The link to the repo playground as well is being provided here. That's really your first place. Another good resources will be the conf test. Here's simply to understand how to install it, how to leverage it. We kind of covered everything we need to know, but this is where you can get started on that site. And then come the Snyk part. And for that, there is nothing better than reaching out to us. Either you're doing it directly from the chat that is available in the Snyk UI, or you simply reach out to us through your customer success. We're going to be delighted to be able to help you in any way we can. Thank you for your attention and your time. My name is Philipp Stemberger, Principal Solution Engineer at Snyk. Goodbye.